No? Okay. Um, on As You Learn, when you go on, I put your final two exam grade days and the final are up here. Um, I think I moved it to the following week because I didn't realize that you had fall break, um, which is next Monday and Tuesday. So there's no school Monday and Tuesday. So your second exam will be on October 21st, and the third exam will be November 11th. Um, the final is Thursday of finals week, December 2nd, from 11 to 1:30. Any questions on that? Is there any questions on the project? Projects due Sunday. Okay. We were working on 6.1 and 6.2, and there's a couple story problems I want to do from it, and then we'll start 6.3 if there's no questions. I'll just write it out. The cost in dollars for manufacturing a particular DVD is C of X equals 15,000 plus 6X. So it's cost in dollars, and X is the number of DVDs produced. A lot of times we want to know what the average of a function is. For instance, if we plug a value in here, it's going to tell us the total cost rather than the cost per DVD. The average cost, you take your function, so for the formula, average, they put a line over the variable, so there would be a line above your function, and that equals the function divided by x. So for this function, then the average, you would just take the function and divide by x. So if we plugged 100 in here, we get 15,600. So this was plugged into the regular function. When you plug it into the original, this is total cost. So if we have 100 DVDs produced, the total cost is 15,600. Now when we plug it into the other one, the average function, we get 156. This is how much you're paying per DVD. So if we're only producing 100, we're paying $156 each. So this cost function tells you the total. This is letting you know how much it costs for each one. Any questions on the difference between the two? Yes, we could. Is there any questions on this part? Now, a lot of times we want to find out what happens if the more we produce, will this cost go down? And that's why we take the limit as x goes to infinity. I'm going to write the function here. So I took our average function and wrote it so we could look at it. Remember when we did last class the limits to infinity? We took the degree on the top and the degree on the bottom. So the degree on the top would be what? Anyone? One. Remember, when there's no numerical value for your exponent, it's a 1. So the degree on the top and the bottom are both 1. Yes. So when there's no number, it's a 1. When the degree on the top and the bottom are the same, we can just use the two largest degree terms and reduce them. The x's cancel, so it's $6. When a large number of DVDs are produced, the cost will be about $6 each. So by being able to find this, then you know when you're looking for somebody to produce them that you should be finding a price around $6 each and not $156 each. So the more DVDs you produce, the closer it will get to 6. Any questions on that? Pause. Could also use the calculator to look at that. If we plugged our cost function in. You don't have to graph it, you just go to table and then plug in large values. 1,000, 10,000, 50,000. Notice we're getting closer and closer to 6. And that's getting closer. So each time we will get closer and closer to 6. But we're talking about a large amount. Any questions on that? Try another one. There's one where it's American Airlines and the cost to fly. It says we did this one earlier, but I don't remember doing it. We might not have covered it in this arch section, but it's the cost to fly X miles on American Airlines could be approximated by this equation. I thought it said it was, must not be. Okay. So this is the cost in dollars. I thought it was a different unit, but it's not saying it. To fly however many miles on American Airlines. They want us to find the limit as x goes to infinity of the average cost function. And then explain what it means. So this is the total cost to fly, however many miles you're going. First, want to find the average cost function, and then take the limit as x goes to infinity. Average cost function, you just take the function and divide by x. What do we get for the limit? Anyone?
0.0738.
Because your degree on the top and the bottom is the same. We cancel our x's and we get 0.0738. Now this was in dollars, so that's approximately 7 cents. Now, what we look at as, because it's infinity, the x value, which is miles. So as the number of miles becomes large, or miles flown, large, the cost approaches 7 cents per mile. Because this is average cost, it would be cost per mile. Any questions on that? positive. Let's look at, there's one on my labs that is similar to this one. It says, the graph shows the profit from the daily production of X thousand kilograms of an industrial chemical. Use the graph to find the following limits. So I want to first find the limit as X approaches 6. If we look down here at X approaching 6, we're at approximately 500. Now, sometimes, and I'm not sure how they come up with these numbers, it might say or want 450. So if you're not getting this one part to give you the correct answer, just do the rest of them and then send me a text and I'll give you the points for that. Because this one, it's kind of strange when it's trying to get you to give the answer. But I would say 500. So the limit as X approaches 6, since both sides are coming in at the same spot and it's continuous there, it's going to be, I would say 500. Any questions on that part? The limit as X approaches 10. When we're looking at it from the left, you can think of a dotted line coming through here. So the limit from the left, that minus sign means a little bit smaller. You can move to the left and notice my lines over here. And the Y value is 1500. So the limit as X approaches 10 from the left is 1500. The limit as X approaches 10 from the right is what? Does anyone want to say?
Would it be 1,000?
Yes. We're going a little bit larger, so we're on the right side. Our line is over here, and it's getting close to the 10,000, or sorry, 1,000. So then what's the limit as X approaches 10? Anyone?
Does not exist.
Exactly. If these two are not equal, this one does not exist. Any questions on that? How about the function at 10? Does it exist? So these ones we're looking as it gets close. This, I'm sorry, I couldn't hear you.
I said I think it's 1,500. It looks like the lines there.
Right, the 1500 is colored in where this one is an open circle. So it would be the 1500. When it's written like this, you're looking for the shaded point, and that's, this one is shaded in where this one's an open circle. So it would be 1500. Any questions on that? The next part asks where it's discontinuous at. Notice it's discontinuous right here because to check for where it's discontinuous, trace the line wherever there's a break, that's where it's discontinuous. So in this case, it would be discontinuous at 10. You always use the X value. It's discontinuous at X equals 10. Any questions on that part? It also asks what might be a reason for that. Well, notice that this is for a company, and this is first shift, and then this is second shift. And how much profit in dollars. Well, they already have the pay in here for these employees, so then the amount of work they make or sell, that starts bringing in profit. But then you brought new employees in, so then it drops because of their pay. And so the cost for them coming in and new employees is probably why it drops. One of the reasons. But you have that second shift coming in, and so this drops because they have to pay those people. Also, production stops. So there's a lot of different factors, but any of your answers would be fine. Is there any questions on that? Use the graph to estimate the number of units of the chemical that must be produced. Okay. So they want to know, use the graph to estimate the number of units of the chemical that must be produced before the second shift is as profitable as the first. Well, the second shift hits it sooner because there's stuff that doesn't need to be done because the first shift started different things up. And so it would be 15. Use the graph to estimate the number of the chemical. Yeah. To get back up where this was, they need to have 15 units. So second shift has to do 5 more because 10's already done. But when they do 5 more, they've got it back up to where it was. So they'd have to do 5 more. They might want the total number. The way I'm reading it, I think they want the total. Use the graph to estimate the number of units of chemical that must be produced before the second shift is profitable as the first. So when the first shift leaves, they've done 10 units. When they do 5 more or 15 units, then they're back up to where they were. Is there any questions on that? Six, three. 6.3 is rates of change. And in the next 2 sections, we're going to learn a long version of the derivative. And then after that, we'll learn a short form. The first one is average rate of change. Between 2 points. So from A to B. This is your slope. It's f of b minus f of a over b minus a. Or if you want to find the y values first, use your slope. It's y2 minus y1 over x2 minus x1. Same thing. It shows how much y changes from A to B. So if we look at so if we want to see how y changes from 1 to 3, we can use this formula. A is your smaller value and B is your larger. So it's f of 3 minus f of 1 over 3 minus 1. Remember, these are just y's. You just plug them in here. If you want to do them off to the side, you can, or you can plug them in here. So we could just say f of 3 is 3 squared plus 2 times 3, which is 9 and 6, 15. And f of 1 is 1 squared plus 2 times 1, which is 3. And then just plug them in. 15 minus 3 over 3 minus 1 is 12 over 2, or 6. If you want, if it's easier, because then you're not remembering as many formulas, when you plug this 3 in, that's the point 315. When you plug 1 in, that's the point 1, 3. So then you can use y2 minus, or y, whichever, 1 over x2 minus x1. Plug them in this way. But either way, you're getting the same answer. It's the slope. Any questions on that? There's one other way some students do, and they just plug it right in. So if we have f of 3, they plug 3 in here. 3 squared plus 2 times 3. That's f of 3. Minus f of 1. 1 squared plus 2 times 1. All over 3 minus 1. So you could plug it in here and then simplify also. So there's 3 different ways you could do the problem. If you calculate this, you would get 15 minus 3 over 2, 12 over 2. No matter how you do it, you're getting 6. Any questions on that? Now what it's telling you is as you go from 1 to 3, the y value increases by 6 units. Any questions on that? Let's try another one. Supposed to be an E. So we're going to find the y value, or where it approaches from x equals -2 to 0 for y equals e to the x. So you're finding the average rate of change. Now it's up to you. This is one we're plugging in into the equation. Might be nice because especially the first one has a long decimal. But do it whichever way you feel, and then we'll do it. Now, I'm plugging it in this way. F of B minus F of A over B minus A goes from A to B. So A would be -2, B would be 0. If you switch them, it's fine as long as you do the opposite in both, just like the slope. F of 0 would be e to the 0 minus f of -2 would be e to the -2 divided by 0 minus a -2 makes that a +2. To enter it, which this one's not too bad entering all at once in your calculator, you need to use a parenthesis though. Otherwise it will only divide into this one and then subtract them. Now the exponential function is with the natural log. It's in little e here. Right there. So you have to second and natural log button and it will come up. And then I put my 0. Now, depending on your calculator, I'll grab the other one in a second. Minus e to the, make sure you use -2 and not minus. Two twice. And go down and put my parenthesis and then divide by 2. Now, some calculators use a caret. When you hit the e to the x on the TI-83, it puts a caret. So then you just put your 0 and close the parenthesis on the exponential, minus, and then bring e back up. and put your -2. Make sure you use the negative. And then close the parenthesis on exponential and close the parenthesis on the top of your fraction. And then divide by 2. Four, three, 2. Is there any questions on that? You make sure you use the e to the x. If you use, here it is, the e, that's e to the first power. So if you end up using this one, then you have to use the caret for your exponent. Second e. It doesn't bring up the exponent part because it's e to the first power. But you can still do it. You just have to hit the caret button. Any questions? One. Go ahead and try this one. Again, if you're going to enter it all at once, you'll have to put parentheses here. And when you hit the ln button, it automatically puts parentheses, so you'll have to remember to close those parentheses. The ln button is the same button as your E, except you don't hit the second button. So I'll put my parenthesis, the natural log of 4 minus natural log of 2. And then I'm going to close the top parenthesis and divide by 2. 0.347. Is that what everyone got? Is there any questions on average rate of change? No? So average rate of change is when you're going from one to another. But there's also what's called instantaneous rate of change. And what it does is it shows how much y changes at an exact value. So if you put in 5, it's going to tell you if you went one more, how is it going to change? Now it looks the same, but we're only going to have an A value. So then we're going to plug it in and we're going to look for the limit. Give you a minute. So we want to find the instantaneous change of this function at x equals 0. This is your A. When we plug it in, it's the limit as b approaches 0 of f of b minus f of 0 over b minus 0. F of b, just plug b into the equation. So it would be b squared plus 2b minus f of 0. Any questions so far? Nothing we can simplify here, so we have b squared plus 2b, and all of this is 0. 0 squared, so this whole thing goes to 0. Any questions so far?
Wait, why did you cross out the 0 squared plus 2 0?
Since it's gonna be 0, we could have put
Oh, yeah,
0
yeah.
here, but since it's 0, we can drop it. If it
Okay,
was a
yeah.
number, though, you'd need to keep it.
Okay.
Yep. Any questions on that? So if you wanted, so that you remember why, you could put minus 0 here. Since that whole quantity was 0, and then limit. So I usually put something that helps me remember, like this helps me remember all of this was 0, or writing this would help. You want to, especially when you're just learning it, that way if you go back to your notes, and you're like, wait, where did this whole thing go? So put some kind of a note so you remember. Now when we get to here, this is usually, if you remember the limits, we plug in and see what happens. So if we plug it in, we have 0 squared plus 2 times 0 over 0, plugging in this limit, which is 0 over 0, which means we need to somehow reduce. Any questions on that? If we would have gotten a number, we would be done. There's two ways, at least two ways you could reduce it. One is to factor. Notice there's a b in common in the top. You can factor a b out. I'll show you both ways, and then you decide which way. but we can pull a B out of the top. Which leaves B plus 2 over B. Now, since this is multiplied, I can cancel these. And I just have B plus 2. And then we plug it in. And we get 2. So at 0, if we went to the first unit, y would increase by 2. So it's telling you how it's changing at 0 in this case, because our A was 0. So if we went one more unit, y would increase by 2. Another way of reducing those there's 3 terms, and all 3 have a B in them. So I can divide each one by B. B squared divided by B leaves B to the first, because subtract your exponents. These two cancel and leave plus 2, and this cancels and leaves a 1. So it kind of skips a step. Then you plug in your value. So either way, you're getting the same answer. What you do want to be careful of is that you don't just cancel these two B's and have B squared plus 2. This answer will give you the same, but other values for B would not. So you either need to factor out the top or divide a B from every term.
Why, why did you plugged in the zeros for the f of a, but not the b squared, and then later you went back in and plugged in 0 for the b squared plus 2b? Like it starts out b squared plus 2b minus, and then you plugged in the zeros for the f of a.
Right.
But then you didn't do it for B, but then later, after you got rid of the A and it was just the B's, you plugged in 0 for B.
Yes. So once you get it all simplified, you want to see what happens as B gets close to 0. So then you're plugging it in here. If we would have plugged it into 0 in both to start with, we would have had 0 over 0.
Okay.
And so you only put it in the 1 until you have it all simplified. And then you can plug it in. So even here we would have 0 over 0. So we'd still need to simplify before we can plug it in.
Okay.
I never thought of that. That's a good question. Yeah, so you want to leave it B until you simplify enough, then you can plug it in. And it's usually you're simplifying till this bottom value or quantity is reduced or canceled. Let's try another one. T. So we want to see what happens as t gets close to -1, or how it changes at -1. So this would be your A. So our A is a -1. First we find f of B. Then we find f of A. Now this one, I didn't write it, but it's instantaneous also. You also know it because they only give you one value. So that will help you know which one you're doing. One minus b squared. If you combine these, 0 again. -1 squared is 1, and 1 minus 1 is 0. So first I plug my 1 in, -1. 1 minus a -1 squared is 1, so 1 minus 1, this is 0 again. So it's 1 minus b squared minus 0 over b plus 1. And we want to take the limit as b approaches a, which was a -1. So if you want to wait to put that limit part in, you could simplify first and then plug it in. I'm just rewriting it to get rid of that 0. But this was 0 again. It's not always the case, just happened the two I picked. If you plug in -1, -1 squared is 1, 1 minus 1 is 0. And plugging it in here, -1 plus 1 is 0. So this would give you 0 over 0, which means you need to simplify. This will simplify because it's the difference of squares. This will factor into 1 minus b and 1 plus b because they're both perfect squares. 1 squared is 1. Any questions on the factoring? These two will cancel. Even though they're in an opposite order, they're all positive. They're the same signs. So these can cancel. Now that this reduced, plug it in. Get the limit. Once you're plugging in, you don't want to rewrite your limit. 1 minus a -1 is 1 plus 1, which is 2. Any questions on that? We'll learn another process in the next section. But is there any questions on doing it that way? Let's try one from the book. It says, suppose that the total profit in hundreds of dollars from selling X items. So profit E of X equals 2x squared minus 5x plus 6. Profit is in hundreds of dollars from selling X is just number of items. Find the average rate of change from 2 to 4. So this would be our A and our B. Now, when we're plugging a lot of things in, it's up to you. So we're going to go f of 4 minus f of 2 over 4 minus 2. Now, you could put 4 in here and calculate it in 2. This one's not too bad, but if you want, you can go under y equals and type your equation 2x squared minus 5x plus 6. 2x squared minus 5x plus 6. And then go to your table. Oh, mine's automatic. So if it's, remember, if it's automatic, go to second table set. Notice my auto is highlighted. Go to ask. Second and quit. Now when I go to table, it will let me plug them in. And I want 4 and 2. And there's your two values. So I think it's a quicker and easier way, and maybe we understand it better because you could see it looking as a point. This is the 0.418, and this is the 0.24. Any questions on that? So if we plugged 4 into this equation, 2 times 4 squared minus 5 times 4 plus 6, we would get 18. Or 2, I said 2. 2 we would get 4, 4 we would get 18. Any questions on that? So then plugging these in, f of 4, 4 was 18, minus f of 2 was 4, over 4 minus 2. Any questions on that? $18 minus 4, 14 over 2, which is 7. So we're finding the average rate of change of the profit. Go from selling 2 items to 4 items. Profit increases by $700. So if we go from, as we plugged in 2 and 4, and X is items, so we go from selling 2 items to 4 items, our profit will increase by, and profit was in hundreds, so $700. Or you could have written it, but either way, because profit was in hundreds, you have to multiply by 100. So it would be $700. Any questions on that? Find and interpret instantaneous change at X equals 2. At X equals 2, and this is instantaneous, so it's the limit as B approaches, remember this is your A. B approaches 2. F of B minus F of 2 over B minus 2. Just go downward. F of B, we're using the same equation because this is A, B. We're just plugging B in here. 2B squared minus 5B plus 6. Minus F of 2. Well, from our table, F of 2, whoops, of course it shuts off right when I go down. F of 2 is 4. So this is just minus 4. Any questions on that? So when you have multiple questions and you're using that same equation, using the table helps when you have to plug different values in. All over B minus 2. Combine your like terms. Two B squared minus 5B plus 2 over B minus 2. Any questions on that part? Wait a minute. Yeah, I did that right. It should factor. Oh yeah. The limit is B approaches 2. Now if you plugged 2 in here, you were going to get 0. 2 times 4 minus 10 plus 2. Yeah. If you plug 2 in the top, 2 squared is 4 times 2 is 8. Minus 10 plus 2 is 0. You will get 0 over 0. So we need to factor it. Because we're getting 0 over 0, we know that one of the factors has to be B minus 2. To find the other one, you can use your factoring rules, or we know this is a factor. So B times what will give me 2B squared. So use the first one to get this. Use the second one to get this. The middle will fall into place. So here, I need 2b. b times 2b gives me 2b squared. This is a negative 2. I need a positive 2, so I need a negative 1. Negative 2 times negative 1 will give me that. I'll show you the other way. Any questions on that way, though? Because we know this factor has to be the same. That's what gets the 0. The other way, which we did before when we were factoring, we took 2 times 2 and got 4. So we multiply to get 4 and add to get the middle value, which is a negative 5. So multiply to get 4, add to get negative 5. And that would be negative 1 times negative 4. When we multiply, we get the positive 4. When we add, we get the negative 5. And then remember, once we do that, we have to divide by the leading term, which is a 2. Putting the x here, because this one doesn't reduce, we get 2x minus 1. Well, ours is a b. And over here, this will reduce, negative 2 over 1. So it's 1b minus 2. These should be b's. So this is one way of factoring it. There's also factoring by grouping. But since you know this is here, you can just figure out the other factor also. Trial and error. Any questions on that? So this is the way we learned it in class. But when you know one of the factors, trial and error is nice. Then these drop out. And the limit as b approaches 2, 2b minus 1. Now you can plug your 2 in. And we get 3. We were finding the limit at 2. So when selling 2 items, if you sell one more, will increase profit by $300. So it's telling you if you're selling 2 already, if you sell one more, how much you're going to make. So instantaneous change is telling you right at that instant. And it's a good thing they use this. I worked for a lawn care company for many years, and the sales manager would use this because he'd say, all right, we've already made, each of you have sold, in this case, 2 lawn care items already. If you sell one more, we're getting $300. When you think about that, that would work in this type of case, because if you sell that customer, you're talking about doing their lawn 6 times during the year. And so it would increase profits by $300, definitely. But that's what that means then. It's telling you right at that value instead of between a range of values. So average range of change tells you between 2 units, where instantaneous tells you if you go one more. Is there any questions on that? The MyMathLab might introduce another term, although it should be in the next section. But if you see marginal rate of change, that's the same as instantaneous. So they mean the same thing, marginal and instantaneous. Is there any questions on that? I don't. We wanna. We'll stop there. So 6.1 and 6.2 are due Sunday, but if you need more time on, it's not a problem. But at least get them started. Now, if you want to start 6.3 and 4, we've pretty much covered everything. It's more terminology. And there's another way of doing instantaneous rate of change that I will show you next class. But is there any questions?